Welcome, everyone. Thank you for taking the time to join us today for our 22nd episode of STEM STEAM activities at home or in the classroom. Today, we're going to be doing some microbit activities. Now I'm going to pass it over to Josh, our main presenter today. Take it away.
I was on mute. Hi, everybody. It's a Wednesday at 4 o'clock Central Time. I feel like I'm on NPR. Microbit talk. Let's talk in a much more soft and happy voice. I'm Josh, and to my left over here is Pete, often called the Pete because he's the only Pete we have. He's handling all the computer stuff. Today we're going to talk about some microbit projects that we've recently put together and documented. They're kind of cool, and they're engaging, high interest things you can show off in your classroom or have the students make because they're not too tough to do. As always, if you enjoy these fine webinars from Nasco Education, you can follow Nasco at all of these Nasco links. Thanks, Pete. Please follow Nasco. These are some fun workshops. I'm not just saying that as somebody who puts them on, but also talk to people at nascoeducation.com. You right there. Thank you, Pete. And if you have any questions, you can always give Jordan a call directly because he loves taking phone calls from people. Jordan's a pretty swell guy. We're going to talk about some microbit. We're using our microbit kits, our bitboard kits that Nasco carries from us, microbit. Don't forget, Pete, we are in a smaller letterbox format here.
At least this week.
This week. I know they're moving to Zoom next week, so it gives a little more widescreen to use. So we have our bitboard system, which we're going to go the overhead on right away. There we go. There I am. So make sure I'm in the right spot. So microbit being a very nice open platform, microbit is this little dude right here. I'm going to take him off and just show above. This is the microbit. If you're not familiar with it, this is basically a little $15 microcontroller. You can find these all over the place, not just from Nasco. You probably have some already if your place with Nasco carries them, but by themselves, they don't do a whole lot. I mean, they do some nice stuff on their own, but you really want to expand the capabilities, which is why we have our wonderful bitboard kit, which expands the capabilities of it, gives you access to more of the inputs and outputs that the microbit actually has on it, as well as being able to plug in additional things like extra sensors and battery holders and servos and other fun things. And our bitboard system is Lego compatible. That's right. As you can see, we have it on Lego system. I go over this project right here and talk about this, but we keep posting tons of project, and we are posting curriculum for this. So if you like the bitboard and our various versions of this we have through Nasco, a classroom set down to smaller versions, there's a lot of fun stuff you can do with it, and including the curriculum. So I'm going to plug this guy back in. There we go. So we have here something we've been working on for a while because we like doing simple robotics, and robotics is always a pain in the keister when it comes to especially middle school or even early high school classes where the electronics isn't that tough. You can always find good electronics examples, but it's the physical mechanics that end up tripping people up galore. Because people keep trying to use like, I'll make a robot out of cardboard, which is easier said than done. Or I'll make a robot out of random household materials, which ends up being an angry Dixie cup that vibrates around. It's not that great. Vibrate away, little guy, vibrate away. Yeah, he's vibrating still. So we like to do things in the Lego environment because Lego is a great mechanical building system that has a lot of versatility thanks to the whole Lego Technics line of products that they have. And Legos are also very inexpensive and readily available, and also very easy to 3D print, which is what we have done today. So what we've done here is we have used this thumbstick right here, which is a very simple thumbstick, the same kind of thing you would find on a PlayStation or Xbox controller, but really it's just two potentiometers, so you could use two potentiometers instead. And we have a single Lego compatible servo here onto our little turntable, which is making this really great sound. And we have a second servo up here, which controls our little grippy arm, which is just a little lever. It just goes up and down. Now in the end, we have actually designed, by we I mean Pete. I sketched this out. Pete.
Collaborative.
It was collaborative.
Yeah,
I was the on a piece of paper dude.
Director.
I was the art director. Pete made it happen. We 3D printed a nice little gripper for this because getting the right Lego parts to be a good gripper was really annoying. And we know quite a few teachers have 3D printers and sometimes struggle to find useful things to do with them. I know we do frequently. So we designed these as open source free to use projects. So it uses only a couple Lego pieces here, like 6 or 7 little Lego spacers and axles. And then the rest of this, the gripper arms and the base, are all 3D printed. And we're controlling that via this push button right here on the side to activate this. and it has two positions. You press it, it opens, and press it, it closes to grip things. This is an early version. We're trying to do different versions of this to make a useful classroom demo. Oh, and here Pete has designed quite a few different Lego compatible components. Actually, this little battery holder down here is just a little spot to stick a battery holder into that has Lego on the bottom, Lego receptors. So we knew that with a lot of different things. Even the thumbstick here has a Lego bottom that we 3D printed out. Once Pete got going, he kept like, what other things do we have around the office I can make a Lego bottom to? Which is why we have so many things are Lego compatible. And we keep cranking out more because we've realized if a 3D printer around, this is a great use, especially with students like, look, it's a practical purpose. We have these little sensors and doodads and servos and thumbsticks and distance sensors or whatnot for our programming stuff, be it Arduino or microbit. The 3D printer is a way to augment those components we already have and make them accessible into the Lego environment or different types of connectors, or heck, take what we have there and remix things galore. But it's a very simple gripper arm, which is way better than anything that we could put together or could find on the internet to be made entirely out of Lego pieces by itself. And so in the end, we end up with, if I can get this back on here without, I am trying to do this from the wrong angle. Oh, Pete's gonna laugh at me over there.
A little bit.
There we go. We have up and down, and we have grippy. Now, you may think to yourself, it kind of works, which is true. It does kind of work. We have another version we're working on with this, where instead of using a servo on the end of here to open and close, we're instead going to use that servo to raise and lower a magnet that we actually will then control with the built-in relay on here. We got a little $5 electromagnet off of Amazon. We have a built-in relay on here, which is just a smart DC switch. Microbit can say turn on or turn off. That's basically all it can do. So that way we could pick up, say, metal pieces with that little electromagnet and move them around a table like a real robot arm would do. The big issue is most robot arms typically use 4 servos to work, X, Y, Z, and then a grippy. Unfortunately, the microbit, just as a hardware limitation, pops like max out at 3 servos it can actually handle, but that's also a ton more weight for the pieces to handle in a Lego environment. That, again, just gets more and more complicated as you go along. So the electromagnet ends up being a very, very nice solution for making a real machinery, piece of machinery that would exist in the real world to move objects around, say, an open area, like in a factory, machines that just move things around on a conveyor belt in a classroom setting with only a few Lego pieces. This isn't really complicated at all. It's 2 gears and a few random pieces we had. Now, Pete's going to show you the better part about here. The code is really darn simple as well. Pete.
For this the robot arm?
The robot arm, yes.
The robot arm. Give me a second here.
He's going to find it. The code isn't very tough, which the big, nice, there it is. So we have this code available as well for microbit, which is the drag and drop interface for microbit. You could do this out of Arduino as well, very simply with any Arduino compatible stuff with some servos, different code obviously. But this is just the microbit format that we used here and have available, which even the bottom right corner, those little grids there, that's actually the screen displays information to show if the grippy is open or closed on the little microbit matrix on here, because Pete loves doing that with stuff. But this is a really great thing that, say, a 6th or 7th or 8th grader could sit down and build out of Lego and make a robot arm from a bunch of Lego components that are here, or expand on it with even more Lego components if they had some, in an environment that is completely risk-free and open-ended, which is what we like about it. So that, yeah, you can cookie cutter this thing or expand on it. For instance, in this example Pete has here, he actually put limits on where the servo could move. So it could only go to certain far right, certain far left, to stop it from flopping all over the place when we had to go just everywhere. But there's a lot of things you could add also into this and expand on as well, which is why we like this. And we keep working on this as a platform, but as it is, this is a very simple just example we put up recently as a, here's the most basic robot arm you can possibly build. And we're gonna keep trying to make bigger and better versions with more Lego. But this is just super simple and a great piece of mechanics you can make rather quickly. I think the only really difficult Lego piece that most people tend to have a hard time finding is the turntable platform here, which isn't that rough to find. eBay. you want to find some of these. A couple dollars for those guys, but everything else is just very standard Lego components, nothing fancy. None of Lego compatible servos that come in all the kits we have. So that's our bitboard grippy arm.
There's a nice video of me operating the robot.
Ooh, do you want to show that video, Pete?
Sure, let's roll.
Let's see.
I will unmute you. Look at the precision of this, right? Pick up and move, drop it down. Wow. All right. That worked out.
There we go. So that's project number one. We're going to have 3 projects today because we have about 30 minutes. Pete is a big fan of binary. A while back we made a, oh yes, everyone's a fan of binary. Pete made a similar version of this project, which you could say you have your different positions of your 0, your digits. So
Josh, that's a 4-bit register.
it's a 4-bit register. Thanks, Pete. So you set basically things as 0, 0, 0, 0, or 1. These positions to 0 or 1 is basically what we've got here. There we go. Off is 1, on is 0, on is 1. So you could move these around, and if you want to say, okay, what is 0, 0, 1, and what does that mean in binary? You could hit a button and it would show up on the little display screen.
Yeah.
Well, Pete wanted to take it the other direction. What if we made a game out of it where we needed to take this number and make it in binary, the opposite, make a game out of it. And so right now we've got 2 there. So let's see if I can do this. So we just put this position down and press this button. I am correct. That's how you do it. Now it says 15. So let's do 8 plus 4 plus 2 plus 1.
Yeah.
I am correct.
Hey. Well, what if you get it wrong?
Oh, I'm gonna get there. Okay, let's just change this a bit. So I'm just gonna do 1. So it's at 1. This says 11. Womp womp. So it's a way to learn binary. Or if you want to take it even further, you can make it into a math game too, where if you want to have a small child, like, okay, what number adds up to 6, or what way can you add up to 6? You can go 4 plus 2. Correct.
Yeah.
So a great math game for young students. Also, very easy project for a kid to use. We have worked with a couple teachers on implementing the other version of this project into classroom activities, because I know it's a learning objective for a couple state standards, and it's a very simple way of learning binary in a format that's fun. Any kid can make this pretty easily. It's just tape and our switches and a push button on this Lego environment, or you could do this on cardboard too if you wanted to. We are using a little 7-segment display, which comes in some of our classroom sets to make this. And so that's really handy to use. And we have some big classroom sets with a curriculum. This is one of the activities that is an extension on that in those classroom sets where you can physically make this with materials in the classroom set. Little battery holder you have plugged into over here. But you could also say change this up and only do, say, 2 digits, for instance. Or Pete was thinking the other day, what if he made it even further, go out even further? I know, Pete, you would just go on for days with so many switches. It'd be just dozens and dozens of switches.
Sure.
As many as we can actually handle here. Pete, could you use more than 1 microbit and add even more, like infinite switches into the microbits?
Yeah, probably, yeah. I mean, we got like what, 15 inputs already, and whatever you could do. A 15-bit register, that's big.
Or just come back and just be like Lego everywhere in the office one day.
Yeah.
That's a nice practical example of a learning tool you could make and have around for students to use at a station. And it wouldn't take you very long as a teacher to put this together as an activity. So we had a fun grippy arm, we have a learning tool. Now we have a practical household project as well. Oh yes, for all those at home who keep killing the things they love, mainly
Just plants, I hope.
plants.
Yeah.
Plants, they're all around us, not just for oxygen, but also to eat. Plants. This is Robert. He's our office plant. Thanks, Pete. I know. Groan, please groan. Well, because we know some people have a hard time remembering to water their plants, we built a plant watering system, which is a great example of using robotics for a practical, like real world industrial application, not just the grippy arm, which would be industrial as well, but say in farming, for instance, you had a hydroponic solution growing vegetables or whatnot in a home or in a factory setting, you could use something very similar to turn on and off water. So what we have here is a little moisture sensor, which is actually just two copper rods here is what it is. I've seen people make these out of nails before. It's very little cheap, like $4 sensor we picked up, just so you can kind of dial things in. But this will give you a value in the microbit that's easy to read. And you can say, okay, what is my dry value? What is my saturated, like in a cup of water value? And determine what's a good amount of water to have in your plant. Now over here, we have a $9 water pump we got off Amazon. And then a 9-volt battery to stay powered off of. And we're using that built-in relay on here as well. And the relay, again, is just a smart DC switch for turning on things like motors, for instance, or that electromagnet we referenced before. And we have, of course, a cup here, which water goes into, and then this goes into our plant. And what happens is this thing basically, if I'm not mistaken on the code, Pete,
Yes.
there is a time, like every so often it checks what is the moisture value.
Yep.
And if the moisture value is below a certain point, it turns on the pump for a couple of seconds and then stops and then waits. And this would go on forever until, of course, there is no water left. Or you could have a big jug of water. But you could keep doing this over and over again because it just keeps reading on there what's going on and turning that system on very easily. So let's see if I can turn this on. It's very boring without water involved, but you know what we have?
You're gonna hear the phone.
Yes, we have a fun video that actually shows this in action, don't we, Pete?
Yeah, let's roll that right now, okay?
Oh, good.
And I will unmute you. Oh no, sadness. Okay. Water. Water. Look at that.
I know.
I know.
Now you laugh about this, but when you live in a household with someone who constantly kills their plants, something like this becomes, a practical thing. Or if you had a classroom plant, for instance, a plant or two in your classroom, which a lot of teachers do, especially science teachers, you could set something like this up or have students build this as a project beginning of the year and then have this in a classroom and have it running as a practical thing. You've built something that does a job in your classroom that you see the output from. You can even run a fun experiment where you have one plant, say you want to grow some tomatoes or some small desktop plant that would be fun, like let's say basil's an easy plant to grow. Let's say basil. You got 2 basil plants in your classroom, one that kids are watering by hand every so often, and one that's being run by this system. You can compare what is their growth rate. That's a really easy science project to take data collection over weeks, if not months, with a practical system that you built that you can then share across different classrooms. So it's really nice, easy data collection because this is a real world application that's happening now. This is a very small scale of computerized industrial farming that's going on these days, where you have machines watering and tending for plants automatically or taking care of different zones automatically. This is just a very, very, very simple format to keep my little tiny desk plant over here alive when we're gone over a weekend or a long weekend. But it's a
What's on those probes? What's
so
on there?
we have found, so this is like the cheapest one possible, like maybe even $2, $2 to $4, like little moisture sensors. There's a bunch of these out there. If you have like a random Arduino kit you've purchased over the years, it's probably in there. And so we found that it's a circuit board, just a bare circuit board, with a strip of copper on each side. We found that just over time, like that copper just corrodes and gets destroyed really, really quickly due to the electrical flow happening between them through a moisture-rich environment in the soil, which happens with any metal that's exposed like that. So we're using some of our nylon conductive tape, which we've used in other places, just over the top of here because it conducts really well and it's a nylon tape. And so we don't submerge this entirely in the soil. We just have some clean copper up top. Basically, we have a changeable surface, a conductive surface we keep adding on and on over and over and over again. So, oh no, these are kind of gross, peel it off, put another piece on, you're good. And it saves that $4 sensor, which is the number one issue. They're cheap, but they also crap out on you really quickly.
Yeah.
This is just a great way to keep it working forever in a day. I think I've seen people use literally nails for this before, where they've just taken the wires off of here and stripped them, taped them to a couple of nails and stuck it into the soil. Again, same purpose. It's a metal object that you're putting in the soil, and you can always switch out nails if you want. So it's just a really easy thing to do, and just a great way of using a inexpensive off-the-shelf sensor with a microbit in a practical purpose environment. And again, all these parts can be used over and over again, year after year after year after year, and have kids every year design their own system. I've seen people do aquaponics is a thing where you use fish like dirty fish water to then water plants as fertilizer, moving water from one spot to another and then back down the filtered water through the plant system back up to the fish tank again, which essentially is a couple of these pumps right here on a timer, or sensing the moisture in your plant level and sucking water through again. Again, this is something people do in homesteading. This is something they do in factory farming situations or in classrooms across the country. And you can make a very simple system with a couple of cheap pumps, especially like a little tiny fish tank and a couple of couple of very small plants in your classroom. The basil, maybe some rosemary and thyme, and get going. But the code for this is extremely easy because really it's what is the value from the sensor, and when the value is below a certain point, engage this thing and then start all over again. Wait a certain amount of time. And Pete, how long is that rest time? Is that 10,000 milliseconds? Ooh.
10,000 seconds.
Oh, 10,000 seconds. Is that 20?
No, I'm sorry. You're right. Milliseconds.
Milliseconds.
Yeah. So I think for this, we were just 10, doing 10, but you could change that to, run once every hour, every day, or whatever.
Yep. And the thing is, if it, if you want to have if you have a cactus that only needs to be watered like once a month, you could set up to check, once a month, or just automatically kick in once a month, even without the moisture sensor, which is a nice part. If you know you have to water your plant every Sunday, have it set up to only go off every Sunday for 10 seconds or 30 seconds with a pump, and have a little water bottle with a sealed top on it. So a practical use application, which is what I love to see happen in the classroom, because making fun things, making angry vibrating Dixie cups is fun and all, and BristleBots and solar bugs, they're fun projects that have a learning objective attached, but this is a functional thing that the kids themselves have built. And they can point out, hey, mom or dad, grandma, grandpa, brother, sister, I helped build this thing which keeps our plant alive, or helps keep our fish alive, or helps do something in the classroom, which is a really fun source of empowerment for students, that they have built this is a real robot. Unlike that grippy arm, unlike most of the things that people call robots, no, those are remote controlled.
Automated system.
This is an automated system. It is a robot. It reacts to stimuli, it compares, and it reacts. It makes a determination. Do I need to do something or not? This is like a super simple it can be. It's a real robot, which is great to point out, and a practical one at that. And this will go for a really long time, as long as you have it plugged into a USB power source, I would imagine. So anyway, that's our 3 projects for the day. If there's any questions, let us know, but we posted all the code directions and whatnot up for use. We're using our Bitboards kit here, which is this guy right here. It has a built-in relay. It has the spots to plug in the servos. Our kits do come with those Lego compatible servos. The Nasco carries all those. The classroom sets do have quite a few things, and these other components, if you want to say do this as a one-off in your classroom, they're very easy to come by. And we just grabbed a random water pump. If Nasco has a random water pump, it'll probably work just as well. I did not look at Nasco's website. I apologize, Jordan. But a random water pump. But definitely, this makes it possible because there's a built-in relay on it, and the easy to plug in stuff that you could not do with just an off-the-shelf microbit. So any questions, let us know right now, because we have a couple minutes left, and I don't want to run over and bother Jordan too long on this wonderful, beautiful Wisconsin Wednesday. Jordan, any questions?
Oh, no bother. Absolutely. Well, I first want to say thanks everyone for joining us today, and thank you, Josh, for presenting, but also Pete for the assistance. Thank you.
Pete's pretty awesome.
My name is Jordan Nelson. I'm one of the customer engagement managers with Nasco. I was your main host today. But like Josh was saying, if you have any questions, you can ask them at this time as you are writing them. I did want to reiterate a few things. If you're interested in ordering, check out some of the links that I put in chat. I also put in some of the links for codes that we have for the microbit. You can also reach out to me specifically at engage@nascoeducation.com. I'm always willing to help out as needed. Let me put that in the chat as well.
It's up on screen too.
at nascoeducation.com. There is a survey afterwards. We definitely like your feedback. If you like what we did, or if you want us to modify anything, we're always willing to listen to that. Even if there's a project that you're saying, hey, you know what, Josh or Jordan, could you potentially make this kind of project? We're always open to ideas. We love that, and we appreciate your feedback. Another thing that's going to be happening, we're going to kind of shake things up a little bit. So For those that have been joining us for a long time, like I said, this is our 22nd episode, but we're actually going to be switching over to Zoom. So no more are we going to be using GoToWebinar. It's going to be a Zoom. So let me put that link in there for the next episode for the Zoom link. It's going to be on May 5th. I just put that in the chat. And if you are watching a recording of this, you can definitely reach out to me. I'm more than willing to send out that registration link for you for next week. And we're going to be doing some more great projects. But like I said, this is a nice, easy way that you could be utilizing STEM STEAM projects at home or in the classroom. This is just a couple of different examples. This is like I said, the 22nd episode. There's a lot more that we've done, a lot more content, a lot more projects. We're always willing to share. I am going to be uploading right now all the different files that we had to as well, some of the building files. So let me take the time right now to actually start getting that loaded as well in the handout section. So just on the control panel, you'll notice that I'm going to start uploading in the section called handouts. Just go on there, click on there. So I just uploaded one file. Now I'm going to be picking a couple other ones too as well to load. And if you don't get a chance to download them today, don't worry. You can reach out to me at engage@nascoeducation.com. More than willing to send that to you as a follow-up as well.
And seriously, if you have ideas for projects, throw them our way, because we always like hearing suggestions for things. Can you make a thing that does this? And a lot of things we make end up being suggestions teachers have given us, or you know, get close with a project, or give some good examples of how to do some more things to it, because it's always when we can make useful things that are also engaging and silly, and these are good. Or if you have like, hey Pete, make this 3D printed thing for us, he might be able to, because he's just making so many 3D printed things, just and useful 3D printed things, none of these non-useful 3D printed things we so often hear about in the news. The 3D printers, you got to find useful things for them. I mean,
absolutely, it's not a means to an end. You want to be able to use the application, right?
I'll say this, Pete is the king of making useful 3D printed things. The number of camera mounts and clips and random things he has built because some plastic thing at his home broke, it's fantastic. The number of 3D printed useful things Pete has made, which is just a good example of what you should be doing a 3D printer, as opposed to, you know, 3D printing off like an action figure, which although is fun, it's not super practical.
It is if you're playing a certain game. But anyways, yeah, I know. All right, so thanks everybody. I don't see any questions. We are ending a little bit early, but that's okay. We definitely have more projects for you next week. Feel free to reach out to us. We're available for questions, comments, and anything else along the way. So thanks again for joining our 22nd episode. Hopefully we see you next week. Have a great rest of your day. Take care, everybody.